Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video, we are going to discuss the PhD interview that I had given for spring 2024. Okay, so the question is, was I selected for this interview? The answer is yes. Okay, so in this interview, I was selected. And in this video, we'll discuss some of the very important interview tips. What all things you should do during an interview. Then some of the important topics, then how to overcome fear when some questions are asked, and at the end some motivation. So coming on to the first topic, that is some of the interview tips. So the first thing that they're going to ask you is to introduce yourself. Okay, so in this what you have to say is you can tell your name, from where you belong, and then you can tell about from where you did your studies. Okay, from where you did your BSc, from where you did your MSc, and so on. Okay, and you can also talk about some of your one or two hobbies. Okay, so after this, so what is the main aim of the interview? Okay, main aim क्या होता है कोई भी एक इंटरव्यू का? They want to check your basic subject knowledge. Okay, whichever field you join, organic, inorganic, or physical, the main aim is to know that how much you know about the basics about the particular field. Okay, so they are not going to ask you very advanced level of questions, but based on whatever you have studied. Okay, जो भी jam, gate और net में पूछा जाता है वही questions पे they will take your interview. Okay, very important topics, very important. Whenever you give an interview, sometimes they will ask you to choose your favorite topic. Okay, favorite topic पूछेंगे. So always choose a simple topic. Okay, where you know that this and this question will be asked. Now stereochemistry. Suppose stereochemistry, you know what all things will be asked. They will ask you either relation between two molecules, or they will ask you question on topicity, or they will ask you questions on finding out R and S nomenclature, and so on. Or let's say spectroscopy. Spectroscopy, what all things they can ask you? Spectroscopy, they can ask you different values. Okay, chemical shift values, or in IR stretching frequency values, or number of signals. Okay, so choose a topic where you know that these and these type of questions can be asked. Okay, so it is not necessary that they will ask you from that topic only, but they will start from that topic. Okay, and then uske baad they will ask you from the other topics as well. Okay, but they will start from that particular topic that you are comfortable. Okay, next question is, this is very important. Okay, I know I've given interviews, you have also given interviews, or if you're going to give an interview, it is a very stressful situation. Okay, you're tensed, you have a lot of questions. You will have question like, अगर question पूछा अगर नहीं आया तो क्या करना है? Okay, if you don't know an answer to a question, what to do? Okay, take a minute, read the question carefully, and if you don't know what to do is, you have to try to solve. Okay, the first thing is that you have to try. Okay, if you don't have any idea about the question, then you can straightforward tell them that I don't know this topic. Okay, so sometimes they will change the topic. Okay, or they will reframe the question, means they will ask question in a different way, अलग तरीके से same question पूछता. Okay, or you have to be honest. Okay, if you don't know, you say you don't know. Okay, don't beat around the bush. Okay, don't they know much better than they are taking interview of you, so they know better than you. So if you don't know, you say, okay, I don't know. You can ask from other topic. Okay, and suppose if you know the answer, and sometimes they ask a difficult question, so very important, you have to ask for help. Okay, you try first. Okay, if it is a difficult question, you try, and very important is you ask for time. Okay, sir, मुझे 1 minute 2 minute दे दो, I will solve, or I need some time to think. Okay, very important to take time. Okay, there is no hurry. Okay, you take your time and then you solve. Okay, solve, or if they are asked you something orally, then you think. Okay, you tell them that I need some time, 1 or 2 minutes, give me some time, and then I will give you the answer. Okay, it is very important to ask for time. Okay, there is at least on an average, all the interviews are based between 20 to 40 minutes. Okay, 15-20 minutes they will give you. So in that time span, you think slowly, logically, think logically, and always be confident. Okay, whatever you know, you be confident. Okay, if you don't know, you say you don't know, but whatever you know, you speak carefully, or you write it down. Okay, they will give you rough sheet, or they will tell you to draw on the blackboard. Okay, so it is very important. So three important things is, first you select an easy topic. Okay, whatever, if they give you a chance to select the topic, start from an easy topic. Okay, like stereochemistry or spectroscopy or general reaction or mechanism. Okay, choose a simple topic. Don't choose a bigger topic which has a broad scope, like let's say name reaction. Okay, so name reactions, बहुत सारे name reactions है, hundreds of name reactions, you will get stuck. Okay, if they ask you something that you don't know, that name reaction, then you will be stuck. Okay, don't put yourself in a difficult situation. Okay. Okay, now coming on to the actual interview, what they asked me, first they told me to introduce. Okay, so first you tell your name, from where you did your BSc, MSc, you tell your hobbies, and that's it. Okay, next they will ask you your favorite topic. Okay, which is your favorite research topic or favorite topic from which they can ask you questions. Okay, so which topic I had chosen is stereochemistry. Okay, you can choose stereochemistry or spectroscopy or aromaticity or general organic chemistry. Okay, they will start from there. Okay, ऐसा नहीं है कि stereochemistry बोला है तो they will ask you all the questions from stereochemistry only. You will see in the next slide. They ask questions from all the topics, but they started from stereochemistry. Okay, so the first question that they asked was, what are diastereomers? Okay, so we all know what are diastereomers. They are molecules having same molecular formula and they are non-superimposable non-mirror images. Okay, non-superimposable mirror images are enantiomers, non-superimposable non-mirror images are diastereomers. Okay, and then they asked what is an example of diastereomers. These are alkenes. Okay, geometrical isomers are also a type of enantiomer. So you take a pause. Okay, you pause the video and you can try this question by yourself. How to convert a cis-alkene to trans-alkene. Okay, you can pause the video and think for yourself before looking at the answer. Okay, so we know that carbon-carbon double bond, it is what? It has restricted rotation. Okay, to convert cis to trans, you cannot just rotate. Okay, rotation across carbon-carbon double bond is not allowed or it is restricted. So what is the solution? Okay, so you think and you try to answer and then you can see the solution. Okay, so there is this concept called as photoisomerization. What is the meaning of this? Photo means light. Okay, and isomerization means conversion of one isomer to another in presence of light. Photo means light. Okay, so this is a topic of photochemistry. So if there is a cis alkene, you start with cis 2 butene. Okay, in presence of light, what will happen is this pi bond will break and both the carbon will get 1 electron. Okay, now you can see it is a carbon-carbon single bond. So now what you can do, you can rotate. Okay, it will rotate across the carbon-carbon single bond and then this methyl will come down, this hydrogen will go up like this. Okay, now this is a stable one. Okay, okay, so now you can see it has come to trans and then both the electron combine to give the trans isomer. So this is called as photoisomerization. Okay, so this was the first question. Then the next question was, how can you convert alkyne to cis-alkene and how can you convert alkyne to trans-alkene? Okay, this was very simple. We know in class 11, 12 also they ask you. So alkyne, you can use a Lindlar catalyst. Okay, if you use H2PDC, okay, H2PDC, that will do complete reduction. Okay, alkyne will be converted to alkane. Okay, so you don't want this complete reduction. You want it to stop at the alkene stage. Alkyne gets reduced to alkene first and then alkane. So you have to stop the reduction at the alkene. So how can you get cis-alkene? How can you get trans-alkene? For cis-alkene you use Lindlar catalyst. For trans-alkene you use the sodium in liquid ammonia. This is called as Birch reduction. Okay, so this was the theory part. Then they asked about what is the mechanism of this reaction. Okay, how you get cis and how you get trans. Okay, so in case of Lindlar catalyst, what will happen? This alkyne will first attach to the palladium. Okay, here you are using what? Here you are using hydrogen, palladium and a catalytic poison. Okay, catalytic poison like barium sulfate. Okay, so what will happen? This barium sulfate will poison the catalyst. So as soon as it coordinate with the alkyne, it will add from the same side. Okay, that is called as a syn addition. Okay, it will add from the same side, that is a syn addition, and that is the reason why you get a cis alkene. Both the hydrogen add to the alkyne from the same direction. Okay, same side, that is syn addition. That's why you get a cis alkene. Okay, this was the first reason. Now, what is the reason for getting a trans alkene? So, in Birch reduction, the first step is sodium. It gives one electron. Okay, it loses one electron and forms a sodium cation or sodium ion. Okay, so first thing is electron will add to alkyne and you get a radical anion. Okay, you get a radical anion. Okay, electron is added here and then pi bond, entire pi bond shifted here to form a radical anion. Okay, the next step is this anion will pick up hydrogen from ammonia. You will get a vinyl radical. So this intermediate is very important. Here you can see both the R groups are trans, okay, opposite, that is there is less steric hindrance. Okay, less steric hindrance. So that's why this is a stable. Okay, and then the other electron, what will happen now? This electron and hydrogen both are added from the opposite side. So now the other electron will add, okay, to this vinylic radical to form a anion again. This again it will pick up one more hydrogen and you get the trans alkene. Okay, so this was the mechanism for Lindlar catalyst and Birch reduction. Okay, so next they asked about the IR data of this propyne molecule. Okay, so what are the different stretching frequency values in an IR spectrum or infrared spectrum? Okay, so carbon-carbon triple bond, okay, where this shows up at 2100 centimeter inverse. Okay, remember what shows at 2200 centimeter inverse? Cyanide. Okay, and then this CH, okay, it is called as sp hybridized CH. Okay, here hybridization of carbon is sp. So this shows at around 3300 centimeter inverse. Okay, a sharp peak. Okay, in case of alcohol you get a broad peak like this at 3300 centimeter inverse. Okay, for alkyne it is a sharp peak and this will show in the fingerprint region. Okay, alkynes generally show in the peak, alkane peak will show in the fingerprint region. Okay, then they asked about the NMR data. First they asked about how many signals will be obtained here. So this is one proton A and this is another proton B. Okay, so how many signals will be there? 2 signals. Okay, so what will be the splitting pattern for this A proton? Here adjacent there is no hydrogen, so n plus 1 rule, 0 plus 1, that will be 1. So that is what? That is singlet. Okay, so this will be singlet, and this one also adjacent to this carbon also there is no hydrogen, so this will also show a singlet. Okay, so the next question was, in this spectra sometime you can get a quartet. The question is why? Okay, so here you can pause and think how you can get a quartet. Okay, so CH3, C triple bond CH. Now here you can get a quartet. How you will get a quartet? So this proton can couple with this proton by 1, this bond, 2, 3, and then this CH2H, 4. So this is called as 4J coupling, okay, or it is also called as long range coupling. Long range coupling. So because of long range coupling, this CH can couple with this methyl, and 3 plus 1 you will get a 4, that is a quartet. So that is the reason why you can get a quartet here. Okay, quartet means 4, like this, 1:3:3:1 signal. Okay, then they asked about the chemical shift value. So this SPCH, it shows around 2 to 3 ppm. Okay, and this sp3 hybridized, this shows chemical shift of around 1 to 2 ppm. Okay, so this was the NMR data. Okay, then they asked about this question. Okay, this is also a very interesting question. Here again you can pause this video and think about yourself. Okay, think to and try to solve yourself first. Okay, so there are different methods for solving this question, but they told to use a shortest route. Okay, and what is the shortest route? So here it is, if you try, if you try, let's say, reduction. Okay, if you, let's say, you try an LAH reduction, then what you will get? You will get a benzyl alcohol. Okay, this and this both are different. This is phenol. They asked how to convert benzaldehyde to phenol. This is benzyl alcohol. Okay, so the answer to this is, so you can see here carbon, in the product a carbon oxygen bond is formed. Okay, what are the different ways of forming a carbon oxygen bond? So basically what you have to do is you have to introduce a oxygen here. Okay, oxygen between this carbon, here you have to introduce an oxygen. So how do you introduce an oxygen? The answer is you can do a Baeyer-Villiger oxidation. Okay, and where will the oxygen insert in Baeyer-Villiger oxidation? What is Baeyer-Villiger oxidation? You convert mostly aldehydes or ketones to esters. Okay, so where will the oxygen insert? At the more electron rich site. So here benzene, this pi cloud is donating, so it will insert at this side and not this side. Okay, so what you will get? O, C double bond OH, then you do hydrolysis. Okay, you add water, this will break, this is delta minus, here you will get H and here you will get OH. So you get the final product, that is phenol. Okay, so this is what this is called as Baeyer-Villiger oxidation. Okay, and then this was the last question. So they gave the structure and they told to draw the chair conformer. Okay, and we know first what you have to do. You have to number 1, 2, 3, 4, 5 and 6. So we know that this bulky group, it should occupy what? It should occupy equatorial position. Okay, if it occupies an axial position like this, then there is a chance of a 1,3 diaxial interaction like this. Okay, 1,3 diaxial interaction. So that is why, okay, that is not stable. Okay, that will make the molecule unstable. So 1,3 diaxial interaction will make the molecule unstable. That is why we put the bulky group at the equatorial positions. Okay, so how you can put the groups? Now this wedge means it is above the plane. So let's say I put here above the plane. Okay, 1, 2, 3, 4, 5 and 6. Okay, then at the third position OH is above the plane. So third position it will be like this. Okay, the position of this carbon is lower, that means the axial bond will be lower. This carbon is above, so axial will be up. Okay, then at the fourth position methyl is below the plane. Okay, so methyl will be below the plane like this. Okay, so this is the final answer. Okay, so you can see both the bulky groups, okay, in fact all the groups, they are what? They are at the equatorial position. This is equatorial, this is equatorial, tertiary butyl also equatorial. Okay, so this was the last question. So you saw how starting from alkyne or alkene, okay, the diastereomers, they started with the basic topics, stereochemistry, then they went on to spectroscopy, then they went on to name reaction, Baeyer-Villiger oxidation, again they jumped on back to the stereochemistry. In this way they will ask you questions from all different topics. Okay, and sometimes, most of the times, they can give you this type of questions, A to B. Okay, they will give the starting material, product, and they will tell you to draw the mechanism. Or another type of question that they can ask is, reactant is given, reagents are given, they will tell you to draw the product. Okay, and then for this product they will tell you to find out the IR, NMR, okay, UV, okay, all these structure determination. Okay, so that's it for this video. I hope you have liked the video and you have found the tips helpful. So I will end up this video with this positive good quote to being positive. Think positive and everything will go well. Okay, all the best for your interview if you're going to give some interviews. Okay, and that's it for this video. Thank you so much.